I would like to present today's speakers and panelists. I'm one of them. I am Violeta. I'm a digital adoption manager for live events in EMEA. I'm based in Bucharest. And today I'm joined by a more technical colleague of mine, Liana, who will walk you through the main topic.
Thank you very much, Violeta. Hello, everyone, and thank you for joining. My name is Liana Lixandru. I'm a digital adoption manager with the customer experience team, and I am in charge mainly of cloud native application development. So today we're going to look at a quick example on how to use Oracle functions and GraalVM to run a Micronaut serverless application. So Violeta, if we could move to the agenda, please.
Sure.
Right. So we're going to look at what functions are, how they work, what GraalVM is and what its architecture is. Then we'll have a quick look at how Micronaut works with Oracle functions, and then I'll guide you through a live demo on one of our cloud accounts. Next slide, please. So let's look at some Oracle functions concepts. So Oracle functions is a fully managed, multi-tenant, highly scalable, on-demand functions as a service platform. So it's a serverless platform. You may be familiar with some others like Amazon Lambda. It is built on enterprise-grade Oracle Cloud infrastructure, and it's powered by an open source engine called the FN project. Functions is used when you want to focus on writing code to meet business needs. Next slide, please. So this is how you would deploy functions onto your development environment. So using the OCI console, you would connect to a Docker registry where using the functions, you would upload your image of your application. And then that function definition is uploaded to the FN server that runs within Oracle functions, and then the function code is executed. So we would use, depending on the programming language, you can use Python, you can use Node.js, you can use Java, and so on. And the way it works is that it runs within a Docker container, your application. So you can either publish them using the functions command line interface, or you can just upload your pre-existing Docker container to the registry and then create a function that uses that container. Next slide, please. So some more about functions, right? So it being serverless and having an elastic architecture means that you don't need to do any sort of administration either on your infrastructure or on your software. You don't provision compute instances, you don't have to manage patches or anything like that. Everything is applied automatically. Your app is highly available, scalable, secure, and monitored. So you can deploy your code, call it directly, you can trigger it in response to events, and most importantly, you only get billed for the resources consumed during the execution. Next slide, please. So these are the supported languages and technologies. This list may evolve in the future, but for now, the main languages that we support are Go, Java, Node.js, Python, Ruby, and of course, we support building images, especially native images, with GraalVM. Next, please. So here you can see a more detailed architecture of how Oracle Functions works, starting from deploying your Docker image on the registry. That can be our own container registry, which is recommended, or an external Docker registry. The external services calling with using signed requests, they call the invoke endpoints of that function. And then the function runs within a container that is running on a subnet within a virtual cloud network. So other resources inside Oracle Cloud Infrastructure can access that function as well. So like I mentioned, it is based on FN project, which is an open source container native serverless platform that can be run anywhere. You can access Oracle functions using the console, using the command line interface, and also using the REST API. And you can invoke the functions by making signed HTTP requests as well. Now let's look a bit at what GraalVM is. So you may have heard of it, but it is a high-performance JDK distribution that's designed to accelerate execution of applications written in Java, along with other JVM languages. And it's also got support for JavaScript, Ruby, Python, and some other popular languages as well. It makes it possible to mix multiple programming languages within a single application while eliminating the call costs. Next, please. So the GraalVM basically adds a just-in-time compiler, which is written in Java, to your hotspot Java virtual machine. So in addition to running Java and JVM-based languages, it also makes it possible to run, like I mentioned, JavaScript, Ruby, Python, and so on using Truffle. So they can directly interoperate with each other and pass data back and forth in the same memory space. Next, please. So this is pretty much how it works. Like I mentioned, it runs within a hotspot VM. We've got the GraalVM compiler on top, and it can execute all the popular Java or JVM-based languages, as well as all the ones that you can see above. So a bit about native image now. So native image is a technology to compile Java code ahead of time to get a standalone executable, which is called obviously a native image. This includes all the application classes, all the classes from the dependencies, all the runtime library classes, and everything that is statically linked from JDK. So it doesn't run on the Java VM, but includes all the necessary components like memory management, thread scheduling, and so on, within a runtime system that is called the substrate VM. This is the name for the runtime components like the garbage collector, the deoptimizer, and so on. And the resulting program has a way faster startup time and a lower runtime memory overhead needed compared to a JVM. It supports Java, Scala, Clojure, and Kotlin, as well as JavaScript, Ruby, R, or Python. And these images, we've noticed that they can start much faster than anything running on a traditional Java virtual machine. Thank you. Next. So let's look at how Micronaut works with Oracle functions. It's got support within it that can utilize GraalVM native image, which can result in extremely responsible serverless functions using very few cloud resources. It can be combined, of course, with our SDK for Oracle Cloud Infrastructure to give your serverless functions access to all the infrastructure products and applications and all your needs. So for instance, you may call, compute instances, you may, I don't know, trigger a script that shuts down your compute instances or starts them up, or you can check how much of data you are using on a certain instance, and everything that is available in the OCI SDK is also available in Micronaut through the OCI SDK and its support for all current functions. So now that we've got all of this settled, we can move on to the fun stuff, which is the live demo. So I will be taking over and sharing my screen. There we go. And first of all, we need some stuff to be installed before we start. So I am using Visual Studio Code as my IDE. Some things that we will need to make it all easier would be the Micronaut command line interface. We would, of course, need GraalVM installed. As you can see, I've got version 22 here installed with native image because it doesn't come installed by default. You need to install it separately, but the extension for Visual Studio Code does that for you, so you don't need to do it in command line, but you can also do it like that, of course. And we also need to have installed the OCI command line interface so we can access the functions. So let's go back here. In OCI, on our dashboard, we would, of course, need to have a network created. So I've got a VCN here that is ready to, it's a public VCN connected to the internet that we will be using to run the application on, the function application. So in order to start, let's first create our function. So we go to developer services, and here you can see all of the cloud native developer options that are available to you, and we will click on functions. And in functions, you will see that in my compartment, I already have some created. As soon as this finishes loading. There we go. So we will create a new application here that we will use. Let's call it Micronaut demo. Let's pick the virtual cloud network and our public subnet and create. And that is all that is needed to be done in order to actually create an application. So an application can contain within it one or more functions, right? So you can then deploy here all of your functions that are, I don't know, related to the specific application, in our case, Micronaut. We've also got here, which is very useful, a getting started guide. Either if you want to use Cloud Shell, which is this tool right here, which creates a virtual machine within the infrastructure that you can use, or if you want to do a local setup. And for the local setup, we need some things pre-installed. The functions command line interface, having set up, of course, an OCI registry, and getting an API signing key. So the signing key, we get it from our profile. You will see here that we've got a group called authentication tokens. And we can generate a token here that will be used basically to log into Docker on our container registry within Oracle Cloud Infrastructure. So I've already created my token and I have it copied somewhere. And now let's move back to functions. And let's start creating our function in Micronaut. So I'll move over to Visual Studio Code. Let's run mn. So this is the command to create a default function, right? So it's mn create function app. The features, as you can see, are GraalVM and Oracle function. If we don't plan on using the native image capabilities of GraalVM, we can just set the features to Oracle function. The name of the package, right, which is Micronaut, example Micronaut demo. The build environment, we can choose either Gradle or Maven. We'll just pick Gradle for our example. The language is Java. And the JDK that we will be using is 11. So just run that. And it has created my application, right? Let's CD into it. And let's look a bit at the code. So we've got here our main class, which, as you can see, is very simple because it's just a quick example to get you started. It extends OCI function. And this quick example just gets the tenancy ID using the tenant ID provider from the OCI function and returns it to our call. So this is what we will use to run our function. Now, what we need to do is we need to go into build Gradle and check here within the tasks. You see we've got some options for building for the Docker build command and for Docker build native. So we need to tell it where to actually upload the image, right? We need to tell it which repository to use. So I will be using, since I am logged in here on Frankfurt and my application is created on Frankfurt, I will be using Frankfurt. So you can find all of these on the documentation, all of the short names for all the regions, but this is basically fra.ocir.io is the URL for the Frankfurt repository. Then we need to tell it the tenancy. And the tenancy name you can either get from here going in tenancy, and then we can see the tenancy information, or easier, which is this, or easier if you've got OCI CLI, we just run OCI OS NS get, and this should return us our tenancy namespace. Here we go. So we'll just copy this and fill it in here. And then we need to give our repository a name. So let's say slash Micronaut demo and save it. if we plan on building a native image, we would have to fill in this as well, obviously, where the project name, we can have the same repository and as you can see, the project name has minus native appended at the end, so we can identify which one is the native image. So once this is done, we will need to log into our container, and we need to run docker login. And the command for logging in is -u for our username. The way the username works is if you're using Identity Cloud Service, you need to give it a tenancy namespace /Oracle Identity Cloud Service /the user. If you don't use Identity Cloud, then it would be tenancy namespace /user. And then we need to tell it which container registry to log into. So it's frankfurt.ocir.io. And it will ask me for my password. This is the authentication key that I have created earlier, which I've got copied here. Just copy that and fill it in. And now we are logged in. Now, what we can do is we can also test this. Let me just go back to our function. We can test it by running GraalVM test. And this will create within the build folder an index.html where we can also see the results of the test if we so wish to. So while this is running, let me see if I can just go there. Let's open a Finder window. Let's go to guides, functions, demo, see, build, reports, tests, test index.html. And this is the result of our test, right? It was successful. And now we can actually build a container and upload it to the container registry. So let's also move here to the container registry so we can see it. So for doing that, we're just going to do GraalW and docker build. Like I mentioned, if we want to build a native image, we would do docker build native. So now this will build our Docker container and upload it to the container registry. And then we can actually create our function. There we go. It took 12 seconds, so that's awesome. Now we can move on to our Cloud Console. If we change the compartment here to the root, because I did in the root, you will see that we've got our Micronaut. So it was in Micronaut demo. Let's do I think we need to do a refresh here. There it is. Okay. So now we go into the developer services, into applications, choose our application. In my compartment, of course. Just scroll down, okay. And here in Micronaut demo, we can create a function. So we're going to call it Micronaut demo and pick from the repository our Micronaut sample. And we can see here the image. Now we need to change the memory. As you can see, you can change the memory from here. By default, it's 128, but we can change it to 256 or 512 and so on. So we'll put 512. If we were to run a Docker native, GraalVM native image, we can select the default option of 128 megabytes because it uses much less memory than if building it the standard way, but we need 512 for this. And then we create it. And this has created our function, and now we can actually call it. So to call it, we can use fn invoke. Let's see, I think it was Micronaut sample. The first invocation, of course, takes a bit longer because it needs to actually start up the container. The subsequent invocations take way less time because it runs much faster. And of course, if you don't use your function, you don't call it for a certain amount of time, it will shut the container down. And then it will need to be started up again the next time you invoke the function. And there we go. Our tenancy ID is, and there is the OCID. So that was it on my end. I will stop sharing now to pass over to Violeta.
I would like to thank you all for attending the session. I would like to thank you, Liana, for presenting the Oracle Functions service. And of course, we are waiting you on future events. Thank you and have a great day.